There's some news that just hits differently. It's not just an update. It's almost like a shift in like the whole landscape. And that's what it felt like when I read that Cern has activated a neutrino quantum field.
Wow.
Like, whoa, hold on. It makes you do a double take because this is not just another experiment. This has the potential to like rewrite our understanding of reality.
Right.
Pushing us into like a whole unknown territory of physics.
Absolutely. What's so captivating is Cern's boldness. They never shy away from those big questions.
Right.
I mean, think about the Higgs boson discovery. It totally changed our view of particle physics. And now they're going even deeper into something more mysterious. Activating a neutrino quantum field. It means they found a way to directly interact with the quantum essence of these unbelievably elusive particles.
Yeah, exactly. And, someone out there's thinking, neutrinos, why should I care? Well, just imagine this. Trillions of these almost ghostly particles are passing through you every second. You don't even realize it. But they're like fundamental to how the whole universe works.
They really are.
So Cern was able to not only detect them, but actually stimulate the field they exist in. That's massive.
Huge.
But it's also causing these strong reactions in the scientific world. Obviously, there's excitement, but there's also this undercurrent of caution about what this all means.
Yeah.
It's like we're not just peeking behind the curtain. We might be opening a door that we can't close.
That's a great point. It raises a crucial question for everyone listening. What are neutrinos and quantum fields in the first place? They sound very abstract.
They do.
So let's break it down neutrinos first.
Right.
You mentioned how elusive they are. They have this tiny mass, almost non-existent. They barely interact with normal matter.
Right.
And they're constantly bombarding us from every direction.
Right.
It's this lack of interaction that makes them so hard to study.
It's like they're these cosmic bystanders. They're everywhere, but they don't really interact with anything.
Exactly.
And for scientists who want to study them, that's a huge problem. Historically, it's been about catching them in those rare moments when they do interact, like looking for a needle in a haystack.
That's a great analogy.
And then on top of that, you had quantum fields, and it feels like we're entering a whole other level of complexity.
It's true. But think of quantum fields like the foundation of reality at the subatomic level.
Okay.
They govern how particles behave and how they interact. A particle isn't actually a solid thing in the way we normally think of it.
Right.
It's more like an excitation, a burst of energy in its corresponding quantum field.
Yeah.
So an electron is an excitation in the electron field, a photon in the electromagnetic field. And of course, a neutrino is an excitation in the neutrino field.
Okay, so hold on. When we hear Cern has activated a neutrino quantum field, they didn't just make a bunch of new neutrinos.
Exactly. It's not about creating them directly. They found a way to interact with the neutrino field itself. They've created conditions that amplify the field's tiny quantum fluctuations to a measurable level, like a still pond. They didn't add more water.
Yeah.
They created a ripple, and now they can study it.
That makes so much more sense. So this research is really pushing the limits, isn't it? Combining the study of these ghost-like particles with this concept of quantum fields. It must be giving us totally new insights into things we could only imagine before.
It really is frontier science. We're moving beyond theoretical math into a space where we can actually experiment with these fundamental aspects of reality.
So how did Cern actually pull this off? I mean, neutrinos are so hard to find. How do you even interact with the field they're in?
It sounds like they used an incredibly complex setup designed to isolate and stimulate the neutrino field.
Okay.
They probably used these finely tuned energy inputs directed with extreme precision.
Wow.
The goal was to create the perfect conditions to amplify the field's natural fluctuations enough to detect them.
So it's like trying to hear a grain of sand falling on a beach, but on a quantum level.
Exactly. It's a great way to put it. Our knowledge of neutrinos used to come from observing the rare byproducts of their interactions in huge detectors. This new approach is completely different. It's about engaging with the field itself to see those quantum vibrations. The challenge is that neutrino interactions are incredibly weak. They had to shield the experiment from any outside interference and precisely calibrate the energy and environment to target the neutrino field.
Wow.
By doing that, they've made these normally hidden quantum excitations accessible for study.
It's kind of mind-blowing to think about going from these particles that go through everything to being able to interact with their very existence. No wonder the scientific community had such a strong reaction. You said it was a mix of excitement and fear. What are the experts worried about?
It comes down to this. Are we messing with something so fundamental to the universe that it could backfire? The universe is a delicate balance of forces.
Right.
Some scientists worry that activating a quantum field like this could trigger a chain reaction that we can't predict.
So like a quantum ripple effect.
Exactly. In the quantum world, small changes can have big, unpredictable consequences. If the neutrino field acts weird because of this activation, it could mess with other fundamental forces that govern the universe.
Yeah.
It's not necessarily about immediate disaster.
Right.
It's more about long-term effects that we can't even imagine yet.
So it's the unknowns that are scary. We have our models of physics, but this experiment is going beyond them.
That's exactly it. Our current understanding is good, but it's not perfect. This experiment is pushing those boundaries. And anytime you do that, there's risk. Plus, there's a big ethical question here. The pursuit of knowledge is important,
Right.
but it has to be balanced against potential risks, especially when we're talking about messing with a quantum field. Some say the potential discoveries are worth it. Others say we need to be extremely careful because we could permanently change how nature works.
It's a huge debate, both scientifically and philosophically. This pull towards the unknown against a responsibility of possibly messing up the universe's balance. It's a lot for the scientific community to consider. You mentioned these concerns aren't just hypothetical, they're based on models and past experiences. Could you explain that?
Yeah, history shows us that big discoveries in physics often come with unexpected problems. For example, think about the early days of researching radioactivity. It eventually led to nuclear power and medical treatments. But at first, we didn't fully understand the risks.
Right.
The concerns about activating the neutrino field come from our understanding of how connected the quantum world is and how sensitive high-energy systems are. Our models are good, but they're still just models. And this experiment is probing a level where those models might not be enough.
It's a delicate balance, this desire to explore the unknown and the potential for mind-blowing discoveries. What are some of the theoretical things that could happen if we learn to control a neutrino quantum field?
Some of the possibilities are truly revolutionary. Some suggest it could lead to breakthroughs in understanding things like time, space, and matter.
Wow.
Imagine having a new way to study the fabric of reality at the most fundamental level.
Yeah.
Some physicists even think there might be connections to dark matter and dark energy.
That's incredible. Dark matter and dark energy are like the biggest mysteries in cosmology. The idea that neutrinos could shed light on them is just amazing. You also mentioned advancements in technology and energy. What did you mean?
If we can understand fundamental particle interactions better through this research, it could lead to new ways to generate energy, maybe by harnessing the weak nuclear force in ways we can't even imagine right now.
Right.
There could also be applications in advanced materials and quantum computing.
It's both exciting and scary to think about. Manipulating the universe's building blocks. It sounds like this activation is just the first step. You said there are talks about follow-up experiments?
Yes, this first activation is like a proof of concept, a way to open the door. But the long-term goal is to see if we can not only observe but also control the neutrino quantum field.
Okay.
It's a long, uncertain path with huge potential, but also lots of unknowns.
So let's go back to the technical side for a minute. You said that quantum field theory sees particles as excitations in fields that are everywhere. Can you explain how Cern's work fits into that?
Sure. In quantum field theory, each particle has a corresponding field that exists throughout the universe. Particles like neutrinos are basically packets of energy or excitations within these fields. What Cern did was isolate and disturb the neutrino field using precise energy.
So they created a specific vibration in the field and studied it.
Exactly. And this real-time observation is crucial. It lets scientists measure tiny changes in the field, study how neutrinos interact in controlled conditions, and compare those observations to the standard model of particle physics.
And what if those observations don't match the standard model? That would be huge, right?
It would be groundbreaking. The standard model is our best explanation for all known particles and forces. If the neutrino field doesn't behave as predicted, it could mean there are new forces or particles we've never seen before. It would force us to rethink or expand the standard model, which has been the basis of particle physics for decades. It would open up entirely new areas of study.
You also mentioned practical applications in quantum technologies. Can you give us some examples?
It's early days and very speculative. But a better understanding of quantum fields could lead to breakthroughs in quantum computing. Maybe we could create more stable and powerful qubits. There could also be new sensors with incredible sensitivity, or even communication technologies using quantum entanglement.
Okay.
But it's important to remember these are just possibilities.
Of course, but the potential is there, which is exciting. But you also mentioned uncertainties and the chance of unexpected results. It sounds like we're really in uncharted territory.
Quantum systems are very delicate. Even small changes can lead to unpredictable outcomes. Cern is working at the edge of what we know, and there's always a chance that stimulating the neutrino field could cause reactions we didn't expect and can't control.
It's clear that this whole thing has caught people's attention beyond the scientific world. The news about Cern's experiment is everywhere. What are people saying?
The global response has been amazing. Major news outlets are covering it, and the tone is often a mix of awe and caution. It's a story about our pursuit of knowledge and our ambition to understand the universe.
It's captured the imagination. I've seen discussions on social media, in academic circles, and even just in everyday life. People are trying to wrap their heads around the idea of us interacting with the fabric of reality.
Yes, there are two main viewpoints. On one hand, there's excitement about a new era in physics and unlocking the universe's secrets. On the other hand, there's anxiety that we're going too far too fast and need to be more careful. People are naturally worried about unintended consequences when we're dealing with something so fundamental.
It's the classic dilemma, the excitement of discovery versus the fear of what we might unleash. And the media plays a big role in shaping how people see it. Some outlets go for the sensational headlines, while others give more in-depth explanations.
That's true. The way the media portrays scientific breakthroughs can really impact public opinion. While attention-grabbing headlines are important, it's crucial for people to have access to clear explanations of the science and a balanced view of the risks and benefits. But regardless of the angle, Cern's experiment has started a conversation about the future of science, the ethics of pushing boundaries, and humanity's place in the universe. It's a story that goes far beyond science labs.
It makes you think about our role in the universe and our responsibility as we learn to understand and potentially manipulate it. So as we wrap up our deep dive into Cern's activation of the neutrino quantum field, let's recap what we've learned.
First, we have to acknowledge how big of an accomplishment this is for Cern. To manipulate one of the universe's most elusive quantum fields. It opens up amazing possibilities for understanding the quantum world. But with this breakthrough come serious concerns from experts about unforeseen risks.
It's exciting to think about the potential discoveries, but we have to be responsible and manage the risks. The debate in the scientific community between pushing forward and being cautious is crucial for science to advance in a responsible way.
I agree. Through debate and careful consideration of all possibilities, we can make scientific progress ethically and responsibly. While we're amazed by the potential for new discoveries, we need to stay aware and think critically about the wider implications of these experiments.
This has been a fascinating and thought-provoking deep dive into cutting-edge science. To our listeners, we'd love to hear your thoughts on all of this. Do you think the potential discoveries outweigh the risks? Share your opinions in the comments below, and if you enjoyed this exploration of science, make sure to subscribe for more weekly deep dives into stories that challenge our understanding and spark our curiosity about the mysteries of the universe.
Thanks for joining us on this journey into particle physics. The story of Cern's neutrino quantum field experiment is still unfolding, and we'll keep you updated as we learn more.
Remember, the pursuit of knowledge never ends, and every big discovery starts with a brave step into the unknown. Keep questioning, keep exploring, and stay curious about the incredible universe we live in.
Absolutely.
Until next time.
See you then.